Okay, Math Box 1.1. You're going to go ahead and complete it, and then when you are finished, you're going to use this to help you check your answers, but you're also going to use this as a reference in case there was an area where you had a hard time on. You can use this as a reference to come back to, kind of watch the video again, how was that problem solved, and then try to resolve that problem again, because these are the types of questions that you're going to be asked on your math test. So you want to make sure that you're able to solve these types of problems. So again, using it, kind of going back to it, whether you got it wrong, using it, again, as another lesson for you to watch to kind of try to understand that concept a little bit better, or using it if you got the question right, just as another kind of review or practice before a test to make sure that you're able to complete all of these things. So again, go ahead and solve all of those problems, and then when you're finished, we'll go ahead and check it together. Okay, now that you have it finished, we're going to start with question number 1. And question number 1 wants you to complete the following problems. And A asks you, what times 30 equals 2,400? And so the easiest way I can tell you to solve this problem is to kind of think of those numbers without any zeros on them. So you have something times 3 equals 24 if I take out those zeros. So let's pretend like I take out all of those zeros. And then I have something times 3 equals 24. Then you have to think to yourself, what times 3 equals 24? And you know that's 8. So you're going to go ahead and write an 8 in that box. But you're not finished yet, because 8 times 30 doesn't equal 2,400, which is where we need to get in the end. 8 times 30 only equals 240. So if that's the case, I need to go ahead and add something onto that 8 in order to make it equal 2,400. And what is that thing that we're going to add on? It's going to be another 0. Okay? So how did I get that extra 0? Where did it come from? Well, if you look at 30, we have 1 0 in 30. But in 2,400, we need 2 zeros. We only have 1 in that 30. So we need a second 0 in this other number, which is the 80. That's where that 0 came from. So 80 times 30 equals 2,400. I'm going to do the same thing with B. I'm going to think of it without the zeros. Right now, I have 2 zeros on this one. 400 times something equals 160,000. So I have 2 zeros on that 400. If I cross off 2 zeros over here, I'm still left with 2 more zeros, which means whatever goes in that box is going to have 2 zeros at the end of it. So you can go ahead and add those on first, like we are here, or at the end, like we did in example A. I would suggest do it first, just so that way you don't forget to add it on at the end. So if you do them at the beginning, then they're already there. Okay? So now you need to think of 4 times what equals 16, and you know that 4 times 4 is 16. So we have 400 times 400 equals 160,000. Again, the same thing with C. This time they changed that problem around a little bit. In example A and B, you'll see that they gave you a blank and then times something equals something. In this one, they've kind of switched it around on you, and the same in D as well. They're giving you a number times a number equals what? So you're really finding the answer this time and not the other number. Okay, so again, we're going to cross off those zeros just like we've been doing. So we know that in our answer, it's going to have 2 zeros because there's 2 zeros here. So I'm going to add those 2 zeros on to the end. Again, I'm doing it first so I don't forget at the end. And then I'm going to think of just the smaller number, 9 times 3 instead of 90 times 30. Try to make it a little bit more simplified. So 9 times 3, you know, is 27. So my answer is 2,700. D is pretty much like that example that we just did in C. They're giving you 800 times 50, and you have to solve that. And so I have 1, 2, 3 zeros here. So I'm going to make sure I add those 3 zeros on to my answer. And then now I'm only looking at 8 times 5 instead of 800 times 50. And we know 8 times 5 is 40. So I'm going to put that 40 there. And that gives us an extra 0, but that's because 8 times 5 ended in a 0. It's not one that I've added like I had in the past. Okay, so 800 times 50 is then 40,000. So these are your answers for question number 1. Question number 2 is a story problem. It says Sarah has 171 baseball cards, Adam has 75, Georgette has 109, and Fadia has 19. Jamal has 125. How many baseball cards do they have altogether? In this problem, the first thing that I want to suggest to you is make sure you don't get stuck on the names. It doesn't matter if you can say Georgette or Adam or Sarah or Fadia or Jamal. What matters is that you just substitute a name in there. The names are not important right now. Okay, so don't get stuck on, oh gosh, I don't know what that name is. Okay, right now, first thing I would suggest that you do is find the question that they're asking you to solve. So in this case, it's going to be how many baseball cards do they have altogether? So go ahead and highlight that. How many baseball cards do they have altogether? Okay, so you now have the question, how many baseball cards do they have altogether, highlighted in your math journal. Now you have to think about what are the key words in this story problem. How do I know what operation I'm going to do? You need to think of all those key words in solving problems. Product, quotient, divider. All of those things are going to help you solve story problems. In this case, what they're asking you to do is find out how many they have all together. So our keyword here, all together, means it's going to be an addition problem. So you're going to take all of those numbers and you're going to add them. So the first thing that I would suggest to do is don't write them all in a row, like 171 plus 75 plus 109 plus 19 plus 125. Don't do it this way. And the only reason why I say don't, it's not that you can't, because you'd still get the same answer, but adding a 1, a 5, a 9, and a 5 is a lot harder than just adding 2 digits at the same time. So what I would suggest that you do is instead of adding 1, 2, 3, 4, 5 digits at once, add 2. And here's how you would do that. I would first take 171, and I'd circle that in my problem so that I know I use that number. The next number I need to use is 75, so I would circle that, and I would add those 2 numbers together. Again, I'm using 2 numbers here, the 1 and the 5, instead of the 5 numbers in the other example on the right. So I'm going to add 1 plus 5, again, always starting on the right-hand side of those addition problems. 1 plus 5 is 6, 7 plus 7 is 14. When I have a double digit, I carry the 1 and put down the 4. 1 plus 1 is 2. So right now I have 246. That's not the end of my problem. I want to know how many they have all together, so I still need to add the rest of the people and how many cards they had. So the next number I'm going to look at is 109. So I'm going to take that 246 and add 109 to that. Again, only looking at 2 numbers. Now I'm looking at the 6 and the 9. So 9 plus 6, 15. 1 plus 4 plus 0 is 5. 2 plus 1 is 3. The next number is 19, so I'm going to add a 19 to that. 5 plus 9. 1 plus 5 plus 1, sorry, 1 plus 5 plus 1 is 7. 3 plus nothing is 3. I'm going to write that same number over here because I ran out of room there, because I still have one more number to add, 125. And then 4 plus 5 is 9. 7 plus 2 is 9. And 3 plus 1 is 4. So 499. But my answer is not just 499. If you wrote that, I would take some points off, because 499 what? Marshmallows, candy bars, dollars. I need to know what unit goes along with that. So you're going to need to make sure that you write 499 baseball cards as your answer. And I would always suggest to circle your answer. With all of this work on this page, it's hard to see as your teacher, what is it that you meant to be the answer? Was it 374? Was it 499? So make sure you circle your answer, and then I know exactly where you want me to look. So the answer for number 2, 499, again, baseball cards. Make sure you have that unit in there. Problem number 3 on your math journal says select true or false for each number sentence. And instead of selecting, since this is the digital version, in your journal you are writing the word true or false. So letter A asks us 120 minus 30 equals 90. Now some of you might be able to do that in your head. I'm going to show you how to do the work that goes along with that so that way you get into the habit of that. Oops, sorry, let me switch that tool. So I have 120 minus 30. Again, for subtraction, just like addition on question number 2, I'm going to start on the right-hand side. So 0 minus 0 is 0. 2 minus 3. Think of it like this. If you have 2 pencils, can I borrow 3? No. So you're going to have to borrow here from that 1, make it a 0. And then the 2 then becomes a 12. So now you're doing 12 minus 3, which is 9. So the answer is 90. That would be true. A quick, easy way to check and make sure that problem is right is take that 90 and add the 30, and you should get the top number. So I'm going to do the opposite operation. This was a subtraction problem. Opposite of subtraction is addition. So I'm going to do 90 plus 30. 9 plus 3 is 12. Add that 0, so 120, which is your top number. Okay, so that's one quick, easy way to check a subtraction problem. The next one, B. B is going to be, make sure you watch B because look at it. It's 1,600 equals 800 plus 700. So they just wrote it different. It doesn't mean anything different, but make sure you pay attention to that. 800 plus 700. We know 0 plus 0 is 0. 0 plus 0 is 0. 8 plus 7 is 15. So my answer is 1,500. That would be false. Here's what I like to see as your teacher. I like to see that work. Okay, you need to get in the habit of showing your work. Because if I say to you when I help you check this, well, if it's not 1,600, what is the answer? And if you don't have anything written down, you wouldn't know. So put it in the margin. That's why that space is there. Okay, so 1,500 is actually the answer for that. Question C is going to be 8,000 minus 3,000. 0 minus 0 is 0. 0 minus 0 is 0, 0 minus 0 is 0, and 8 minus 3 is 5. So that one's going to be true. Question D, 6,000 plus 5,000. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0, 6 plus 5 is 11. Putting in my comma, 11,000 would make that answer true. Okay, question number 4. We're going to be looking at some bar graphs here. Just like we look at some data in science, we look at a lot of data in math as well. Okay, so we're going to use that bar graph to help us answer a couple questions. First thing is important, make sure you look at that title. What is it that I'm looking at? Am I looking at the number of candy bars that students like? Am I looking at how many hours they spend on electronics during the day? What is it that data is showing? And in this case, it's showing the 5 snowiest winters in Chicago. The next thing I would suggest that you look at is how is that data recorded? What numbers are they using? And in this case, on the other axis, they're showing you 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Well, does the 10 really mean 10 or does it mean 10 billion? Does it mean 10,000? What is it actually showing you? So we're going to look at that label as well, just again like we do in science. So this is looking at snowfall in inches. So when they say 10, they really mean 10 inches, not 10 million, not 10 people. Okay, so snowfall in inches, 10 would be 10 inches. Okay, so the first question in number 4 says, about how many inches of snow are represented on this data set? So in order to figure that out, you are going to look at all of the snowfall in inches for all of the different years. Okay, how many? About how many means average. Give me an average of how many inches a year. Okay, so what I'm going to do is take all of those numbers and add them up. Okay, so again, about how many inches are represented in the data set. So looking at 1917 to 1918. How many inches in 1917 and 1918, we're looking at, again, that's asking us for an average, about how many. So we're going to round that to 70. It's more than 60. In 1969 to 1970, we're going to say about 80. Again, rounding that number. Just like in problem 3, I want you to add 2 numbers at a time, not a whole list of numbers. So 0 plus 0 is 0. 7 plus 8 is 15. And I could put a little X on these because I know I used those too. 1977 to 1978, we're looking at about 80, a little bit more than 80. So again, we're rounding that anyways. So in the end, we'll figure that all out. 0 plus 0 is 0. 5 plus 8, 13. 1 plus 1 is 2. Put an X on that because you know you use that data. 1978 to 1979, we had about 90. 0 plus 0 is 0. 3 plus 9 is 12. 2 plus 1 is 3. Putting an X on that, we know we use that data. Again, I'm going to move my number up here just because I'm out of room. So I have 320, and I still need to add 2013 to 2014. We're going to say that's about 80, following that line all the way over. Okay, about 80. 0 plus 0, 2 plus 8, and 3 plus 1 is a 4. So there's about 400. Again, make sure you put that unit. If you just put 400, I'm going to take some points off. 400 what? Inches. Okay, so 400 inches of snow are represented on this data. And again, I use that last one so I can put an X on that. The next part of this question says, how much snow fell in the least snowiest of the 5 winters shown? I'm going to switch colors just to kind of make it a little bit easier to kind of distinguish between these two problems. So I'm going to switch to blue here. How much snow fell in the least snowiest of the 5 winters shown? So first we need to find which one had the least amount. That's going to be 1917 to 1918 has the smallest bar. And then we need to find out how much of that snow fell. And again, it's asking us the least snowiest. That's what I would be highlighting. And then you're going to write, hopefully you wrote, about 65 inches. And your printing hopefully looks a little bit neater than mine. Trying to do this with your fingers a little bit awkward, so excuse the chicken scratch for a minute. So about 65 inches of snow fell in Chicago in the least snowiest month. Some of my favorite problems to do right here, writing fractions as a mixed number or a whole number. So how do we go about doing this? Well, we look at problem A, actually all of the problems, but looking at specifically problem A, is an improper fraction. Improper fractions occur when you have the bigger number on the top of the fraction sign, and we call that top number in a fraction the numerator. So you'll see that 35 is bigger than 3. Sorry, again, I forgot to change it back to the pen. 35 is bigger than 3. Okay, so that makes that an improper fraction. So how do we change that to a mixed number or a whole number? Well, it's going to be a mixed number if I have something left over, if it doesn't go in evenly. I'm going to have a whole number if the denominator goes into the numerator evenly. Okay, so if the bottom number goes into the top number evenly, then I'll have a whole number. If I have anything left over, I'll have a mixed number, so I'll still have a fraction as well. So let's look at A. You're going to ask yourself, how many times does 3 go into 35? How many times is a division problem? So you're going to set this up like a division problem. So 3 goes into 35. How many times? So I'm looking at 3 goes into 3. How many times? 1. 1 times 3 is 3. When I subtract, I get 0. Bring down your next number, which is 5. Always write that arrow. Make the arrow go down to your equal sign here. How many times does 3 go into 5? 1 time. 1 times 3 is 3. When I subtract, I'm left with 2. 2 is my remainder, so I know it's going to be a mixed number. So my whole number is going to be 11. It needs to be bigger than your fraction part of it, so I know what is the whole number, what's the numerator, what's the denominator. So make sure you make that distinguished so that I can tell the difference, okay? So 11 is my whole number, the number up top, okay? Now when I have to figure out my fraction, which number comes next? As my numerator, I'm going to look at whatever I have as a remainder. Your remainder better be smaller than what you're dividing by. Otherwise, you did something wrong. Okay? Again, I'll say that one more time. Your remainder better be smaller than what you're dividing by. Otherwise, you did something wrong. Okay, so I'm looking at my 2. 2 is smaller than 3, the number I divided by, so I'm okay. So I have a 2 as my numerator. My denominator is going to stay the same. So here it was a 3, it's going to stay a 3. So my answer is 11 2/3. The only way your denominator would be different is if you have to reduce that fraction. 11 2/3 cannot be reduced, so that is going to stay my answer, 11 2/3. I'm going to leave that work up there while I solve problem B, but then I'm going to erase a little bit of it so that it gives me a little bit more room and kind of focuses your attention on what it is as the answer and not all the rest of the stuff on the page. So I'm going to leave that up so you can kind of use it as a reference for B. So B, again, an improper fraction. The numerator is bigger than the denominator. So you're going to ask yourself, how many times does 11 go into 19? You can set it up as a division problem like we did for problem A, but hopefully you're realizing that 11 goes into 19 only one time. Can't go in 2 times because that would be 22. So just go ahead and write the 1. Okay, so 11 goes into 19 one time. Now you need to think, how many are left over? Well, that's going to be 19 minus 11, which is 8. Sorry, don't know what happened there. Must have hit a button. Which is 8. So 8 is my numerator. Again, my denominator, remember, is going to stay the same. So 1 8/11 is going to be my answer for number 5B. 5C, I'm going to go ahead and erase a little bit of this so that you can see things a little bit better. Hopefully you can erase it. There we go. Okay, that's a little bit neater, and it gives us a little bit more room to do the work for the next 2. 72/7, again, is an improper fraction. This one, again, is one like A. I would want to set up as a division problem. 7 goes into 72. Make it a little bit easier on yourself. 7 goes into 7 once. 1 times 7 is 7. When I subtract, I get 0. Again, I'm going to bring down the next number all the way to the line, that equal sign. So I'm going to bring down that 2. 7 does not go into 2. You have to write a number as a placeholder. So if 7 doesn't go into 2, I need to write a 0 as a placeholder because I brought that down. That wasn't my remainder. It was the number that I brought down. So 7 goes into 72 10 times, and then 2 are left over. So my whole number is going to be 10. My numerator is going to be 2, which was that remainder. And then again, remember, my denominator is going to be the same. So 10 2/7. You can't reduce 2/7, so that's going to stay the same. For D, 36/6 is an improper fraction. How many times does 6 go into 36? Hopefully you know those facts and you know those doubles really fast. And if you know the doubles really fast, you can easily answer this question. 6 times 6 is 36, so 6 goes into 36 6 times. So your answer is a whole number for that because there isn't any remainder. Okay, so for D, your answer is just 6. Again, if there's no remainder, then you have a whole number. If there's a remainder, you'll have a mixed number, so a whole number and a fraction. That's your answer for number 5. One of my next favorite types of problems is ordering fractions. If you try to order fractions based on their denominator, you're going to have a really difficult time. I highly suggest you know how to divide, so I highly suggest you use that skill and start using it right away so you get in the habit of it. It will make your life a lot easier when you're ordering fractions. So this one, wants me to order these fractions from the least, I'm so sorry, I forgot to change that pen again, from the least to the greatest. That's important. I would highlight those two words, least to greatest. So I'm going to have my smallest fraction first, and then my biggest fraction last. How am I going to find out which one comes first without just saying, well, I know 1/2 is 2 and 20 if I compared those two numbers? Don't get caught in that trap, okay? Again, find a decimal, divide those fractions and find a decimal, and then put them in order by their decimals. So in order to do that, you're going to look at 1/2. Here's how it works. Always try to give you a catchy way to help you remember what has to come first. Your denominator is at the bottom of a fraction. Don't forget that. That denominator is so tired of being last that it wants a chance to be first. So if it wants a chance to be first, it's going to go in front of the division sign this time. Okay, so there's a chance to be first. So 2 divided by 1. I'm going to take that numerator, which is 1, and I'm going to put it inside the division sign. And your homework tonight is to tell me what those two numbers mean. The 2, what is the fancy math word that we give that to? It's not the number in front of the division sign. The 1, what's the number that we give the 1? It's not the number inside of the division sign. What do we call those two numbers? That's part of your homework tonight, so make sure you find out the vocabulary for those two numbers. Okay, but how do we solve this problem now? Well, we know that 2 doesn't go into 1 because 2 is bigger than 1. So you're going to have to add a decimal. I always say just add 2 zeros after that. 1 is the same as 1.0. You add a decimal. So 1 and 1.0 is the same as 1.00, 1.000. It won't matter how many zeros you add on to the end of that number. If you have a decimal in there, it's going to be the same number. So now I know I'm going to have a decimal in my answer. The first thing I'm going to tell you when you have a division with a decimal, put that decimal up first so you don't forget to put it in your answer. So I'm going to put that straight up. Just follow that line straight up, which is going to make where you put that first number so important. So we're going to use an X in this case, or a 0, to help us be a placeholder. So we know that 2 does not go into 1. So I'm going to put a 0 there. You have to put that 0. Either put a 0 or a small little X in that spot. Because if you don't, your decimal is going to be in the wrong place. Okay? So 2 times 0, 0. I still have a 1. But now I'm going to bring down that next number, 2 into 10. 2 goes into 10 5 times. 5 times 2 is 10. And 10 minus 10 is 0. I can stop right there. I didn't actually need to add that second 0 because I have a remainder of 0 here. I would only have to add that second number if, let's say, it wasn't a 0. Okay, but if I added it, draw my arrow all the way down to that equal sign, and now 2 goes into 0 0 times. So again, anytime I add a 0 at the end, it's going to stay the same. So 0.5 is the same as 0.50. 0.5 is the same as 1/2. 0.50 is the same as 1/2. So we're just finding fractions that are equivalent here. Okay, so 1/2 is the same as the decimal 0.5, which is the same as the decimal 0.50. Okay, so you get it. Now, how many zeros I add at the end doesn't matter. It's still the same number. Okay, I'm going to do the same thing with the rest of those numbers. So again, that denominator is tired of being last. It wants a chance to go first. You're going to find out tonight for homework what is the fancy math word for what that number is called in front of the division sign. 3 goes into 1. Numerator comes inside the division sign. Again, part of your homework is to find out what that number 1 is called. It's not the number inside of the division sign. What do we really call it? What's the math vocabulary for that number? Okay, add that decimal in a 0. Again, I always like to add 2 if I have to use it, and if not, then that's fine too. 3 goes into 1.00. Oh, it's a decimal, so I'm going to add that decimal up top first so I don't forget to put it in. 3 goes into 1 0 times. Okay, 3 doesn't go into 1. 3 is bigger. So 3 into 0 one time. Now it's going to be 3 into 10. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down that 0. Here's that remainder, why I need that second 0. 3 goes into 10, 3 times 3 is 9. Subtract and get 1. So hopefully you're seeing a pattern there. So I can put the line 0.33 with a line over it because I know that same number is going to be repeating itself. Doesn't matter how many zeros I add, I'm always going to get a 10 here. Okay? So 1/3 is the same as 0.33. So right now, 1/3 is smaller than 1/2. Do the same thing for 1/9. 9 goes in front. My numerator is a 1. Add a decimal and 2 zeros. 9 does not go into 1, so I'm putting a 0. And that decimal, don't forget that decimal should be the first thing that you put up. 9 now goes into 10 one time. 1 times 9 is 10. 10 minus 10 is 0. Bring down that 0. 10 into 0, 0 times. Okay? So 9 goes into 1.0, 0.1 time. Next one, 1/4. 4 goes into 1.00. Put my decimal up there at the top. 4 does not go into 1. 4 into 10, 2 times. 2 times 4 is 8. 10 minus 8 is 2. Bring down your 0. 4 into 20 is 5. 5 times 4 is 20. And 20 minus 20 is 0. One more to go. 20 goes into 1.00. How many times? 20 does not go into 1. Put your decimal up there. 20 does not go into 10. There's another 0. 20 goes into 100 5 times. 5 times 2 is 10. Add the 0 at the end. So 5 times 20 is 100. 100 minus 100 is 0. Now, I have all of them in decimal form. Hopefully this is going to be a little bit easier for you than actually trying to guess which one's bigger and smaller. Now I can just compare those decimals and look and see which one's bigger. Okay, I'm going to switch colors here just for a minute because I'm going to take all those decimals and I'm going to write them just at the top here. So I have, and I'm going to write them over, where the work is for that problem. Okay, so this is going to be 0.50, 0.33, or 0.33, and 0.50, 0.10, 0.25, and 0.05. So if I was reading these numbers, I'm going to put commas here so I can distinguish the difference between each number. If I were reading these numbers, that would be how I have it written: 5/100ths. I apologize. First one, not 5/100ths, 50/100ths, 33/100ths, 10/100ths, 25/100ths, 5/100ths. Okay, again, this could be written as 0.5, 5/10ths, and this one could be written as 0.1, 1/10. So make sure you know those differences. Now, I'm going to take those and put those in order. Looking at the first one, first number, first digit, I should say, first digit. I'm going to switch colors again. They all have a 0 to begin with. So I need to look at the next number. Which number is the smallest? Next number, the smallest, because again, I want it to be the least to the greatest. So my smallest number in this set of data is going to be the 0, okay? So that 0.05 was, again, this fraction here, which was 1/20th. So 1/20th is going to be the smallest. I'm going to write that down here. It's going to go 1/20th. So then I need to look at the next smallest number. First I had 0. Next smallest is going to be a 1. So 1/9 is going to come next. I look at the next smallest number. Is there a 2? There sure is, 0.25, which was 1/4. Again, remember, you're writing the fraction that it is, not the decimal. After a 2 comes a 3. There's a 3 here, 1/3. and then finally the 5, which was, again, 1/2. So my fractions in order from the least to the greatest are going to be 1/20, 1/9, 1/4, 1/3, and 1/2. Again, get in the habit of doing the division part of this right away, because pretty soon you're going to be having fractions that are a little bit more difficult than this. And if you don't know how to turn those fractions into a decimal, it's going to be a little bit more difficult. So get in the habit of doing that division, looking at those decimals, and then putting the decimals in order based on, least or greatest. Okay? And that's the answer to question number 6. Now, what do I need you to focus on? Not that everything on these pages for the math box that we just did aren't important, because everything on these math boxes are something that you should know how to do. For your Unit 1 assessment, you need to know how to put fractions in order. They might give you, put them in order from least to greatest. They might give you, put them in order from the greatest to the least. Make sure that you know how to do question number 6 specifically for that Unit 1 assessment. Not that that's going to be the only thing on your assessment, and not that the other problems are not important, but number 6 you will see on the unit test. So make sure you know how to do that one.